Good day everyone, welcome back to Apex Electronics Laboratory Embedded System class. In this lesson, we want to look at how we can interface liquid crystal display to Arduino microcontroller. There are different types of LCD. We have the 16 by 2 LCD, we have 16 by 1 LCD, we have 20 by 4 and the likes. We also have graphics LCD. The 16 by 2 LCD simply means it has 16 columns with 2 rows. In the code, we include the LCD library. This LCD library, once you install your Arduino IDE, your LCD library has been installed already. Just include this library to your work. The 16 by 2 LCD we want to make use of, generally it has 16 I/O pins, but we only need 6 data pins to connect to our Arduino microcontroller. Now the 6 data pins that we need, we want to attach it to pin 7, 6, 5, 4, 3 and 2 of our microcontroller. So to do that, you say liquid crystal LCD, then you open a bracket and you type those numbers. Mind you, for the 16 by 2 LCD, we have 16 I/O pins on the LCD, but we only need 6 data pins to be connected to our Arduino microcontroller, and those data pins, they are 6, 5, 4, 3 and 2. RS of the LCD will be connected to pin 7, while the E will be connected to pin 6, D4 to 5, D5 to pin 4, D6 to pin 3 and D7 to pin 2 of the microcontroller. In our void setup, we have to call a command of LCD that says lcd.begins 16 by 2. This 16 by 2 simply means we are telling the microcontroller that the LCD we are using is a 16 by 2 LCD. So if it is 20 by 4, you change this one to 20, 4. This line of code is used to clear your LCD. So you just say lcd.clear, so it's going to clear the LCD, nothing is going to display on the LCD. Then if you want to start writing on your LCD, we use lcd.setCursor. That is, you set cursor at column 2 and row 0. Now the counting of LCD is start from 0. We have 16 columns and 2 rows. For that 16 columns and 2 rows, you start your counting from 0. So it will start from 0 to 15, making 16 altogether. Now those characters, the words you want to write on your LCD, they are called characters. If you look at this welcome to, altogether it has 10 characters. Now I want to write this. I want to start writing this welcome to on first row of the LCD. The first row of the LCD, meaning is going to be 0. It's not going to be 1 because you start counting from 0. So it will be 0, that is row 0, which is in real life row 1, row 0, then at column 2, because the LCD has 16 columns, so you start from 0, 1, 2. So at column 2, I want you to start writing welcome to. Then for row 2, which is this, I want you to write Apex Elect Lab, that is Apex Electronics Laboratory. If you count all these characters, they are all 16, including the space. Space 2 is a character, dot 2 is a character, slash is a character. So all of them, if you count everything together, it is 16. So I now want to start writing this Apex Elect Lab from column 0, that is the first column, so that is going to contain it. So the first column, write A there. Second column, which is 1, write P, and the like. So delay these two write up, delay it for 1 second. So after that, in our void loop, I clear the LCD again, meaning I cleared what is written here before I write another thing on the LCD. That's the function of clear. So I clear the LCD because I want to write another thing again. So I now say LCD dot set cursor to 0, 0, that is 0, the code, that is column 0, row 0. Start writing Apex Elect Lab. Also, in the second row now, which is this, so start writing number of second is equal to this place. I want to display the number of seconds at which my code starts executing. So the number of seconds is displayed on column 0 and row 1, which is the next row now. So I now set the LCD cursor to column 13, row 1. So from that column 13, row 1, start displaying this time now to our simulation. Now I want to rotate this arduino so that it's going to connect to my LCD easily. So if you want to pick your LCD, just type LCD. So we have different types of LCD, but the LCD we want to use is 16:2. This is 16:2 alphanumeric LCD. Alphanumeric simply means the LCD it can display both alphabets and numbers, both alphabets and numbers. Now, pin 1 of the LCD is VSS, which is ground. So connect it to ground. VDD is power, which is 5 volts. So connect this to 5 volts to VDD as well. The VEE here is contrast. This contrast simply means if you want to increase the brightness of the LCD. In this simulation, it will not work, but we have to include it so that when you want to do your real life simulation, you won't forget. So pick what we call variable resistor. So if you need a variable resistor, just type POT. So the POT we need is POT-HG, the active one. Just click OK, then you paste. Now for this resistor, we need a power to power this resistor for us. So click on power, then you need a ground to ground the variable resistor. Then at the middle of the resistor, now connect it to your VEE. So with this, you've successfully powered your resistor. Now RS is connected to pin 7 of the microcontroller. Don't forget pin 7. Then RW is connected to ground. So just go and connect it to ground. No, this is ground. Connect it to ground. Then E is connected to 6, pin 6 of microcontroller. D0, D1, D2 and D3 on our LCD, we are not using those pins. We start from pin D4. So D4 is connected to 5, D5 is connected to 4, and D6 is connected to 3, D7 is connected to 2. So this is the connection. Then compile your code and copy your X path. So Ctrl C, and on your simulation double click on it. So Ctrl V to paste, click on OK, and you play. So you can see, welcome to Apex Elect Lab. It's going to display this for 1 second, and after that it's going to display Apex Elect Lab. So number of seconds, so it's going to start counting from 1, 2, 3, and the likes. So this is the simulation of liquid crystal display. So try yours and let's see what you've done. Goodbye.